everybody. We are going to do a chemistry experiment together. Now, chemistry is the study, it's like science, it's a part of science, it's the study of what things are made of and how those things interact with other things. So, today we're going to look at the chemistry of whiteboard markers. So, for this experiment, you will need a plate. You can also use a cookie sheet or a glass baking dish, just something that you can write on. But don't worry, it's not going to ruin whatever you write on for moms and dads out there watching this. You're going to need some warm water and some whiteboard markers. Now, it's very, very important, boys and girls, that we use whiteboard markers because whiteboard markers are a little different than regular markers. You can wipe away whiteboard markers, but you can't wipe away permanent markers. So make sure that you use the dry erase markers or whiteboard markers for this experiment, otherwise it won't work. So we're going to draw some pictures on a plate or your baking dish or cookie sheet or whatever with our whiteboard markers, with the dry erase markers, and then we're going to try to use the water to make them float up and so they can move. Now, you're going to draw your pictures and then it needs to dry for a little bit. The ink needs to dry from the markers. So I have another plate here already that I drew some pictures on. You can see I have a star, a sunshine, and a little guy with a balloon. So this has been drying for a couple minutes. And like I said, the reason it's important to use whiteboard markers in this experiment is because what the ink is made of, the chemical makeup of the ink in these markers is different than regular markers, than something like this permanent marker here. This permanent marker, the ink is meant to stick to whatever you write on so that you can't get it off. That's why it's called permanent, because it always stays on. Now, something like a whiteboard marker, the ink is a little different. It's made to be wiped away so that you can erase your whiteboard. So this ink is not sticky like the permanent marker ink is. So it's not going to stick to your plate or whatever you're trying this experiment with. That's why it's so important to use these types of markers, because if you were to use a marker like this, the ink would stick to the surface of what you're drawing on and it would be very hard to get off. But we're using dry erase whiteboard markers that are not sticky. So once you have your picture and it's dried for a little bit, you're going to very carefully, tilt this down so you can see, with the help of a grown-up, pour some warm water very slowly onto your plate. And the ink should float right up. You can see our star did. I might have used the wrong type of marker. I used a thinner marker for our little guy there, but we can still look at this experiment with the star. Now, boys and girls, this is I'll just leave that there. This is an important thing when we're learning about science experiments and chemistry experiments. They don't always work the way that you think they will. And that's okay. That's part of what science is. So even though this didn't quite turn out the way that I wanted it to, we'll still be able to learn from it. So I'm going to move my plate a little closer and tilt my camera down so you can see that my star, even though it broke apart, is moving around. Look. And I can blow it around my plate. And the balloon is starting to come up a little bit, but I think you need to use, it looks like a thicker marker works better than the thin markers. So that is an important thing to know when we're doing these experiments, what markers work best. So you want dry erase markers, and you probably want to use the thick-sided marker. So what did we learn? We learned that whiteboard marker ink isn't sticky and it won't stick to the surfaces. We also learned here that the ink will float on top of the water like this. Well, our balloon's starting to come up. Oh, there it goes. You see it? There it goes. How cool is that? Now watch it. Let's see if I can move it around with my finger. We get our star out of the way, then I'll blow our balloon. Oh, it broke away from his arm. How silly is that? All right, so back to what we've learned. We've learned that whiteboard marker ink isn't sticky. It does not adhere or stick to surfaces like the same way that other markers do. We've also learned that the ink will float. Now, this tells us that whiteboard marker ink is less dense than water. And dense is just a scientific word that we use to talk about how heavy something is. So we know that the water is heavier than the ink, so it'll go to the bottom, and the ink is lighter than the water, so it'll float to the top. And the word for that is density. So the marker ink has a lower density than the water, which is why it floats on top. And something else that we've learned just through our experiment here is that sometimes experiments don't always go the way that we plan. But that's okay. That's why they're called experiments, so that we can learn from them and try again. So maybe when you try this at home, you can fix my mistakes. You can use a thicker marker, maybe some warmer water, and see if you get a different result. I've also seen that you can do this where you draw little people and then you can blow and have a race to the edge of your plate. So maybe you could try something like that. Well, this was a very exciting chemistry experiment with results that I didn't quite expect, but I think we still learned from. Ooh, I bumped my plate and it moved our star pieces in the balloon. And the balloon broke away from its string. Do you see that? Well, even though this didn't go quite how I planned, I hope you still enjoyed it and I hope you still learned from it. And I hope you have fun trying out this chemistry experiment at home. Bye, boys and girls.